The sun looks calm from Earth, but it's actually a turbulent ball of hot gas, sometimes unleashing violent solar storms. These storms send waves of energy and particles racing through space, and when they hit Earth, they can disrupt our technology in ways we barely notice, until something goes wrong. Imagine your GPS failing or a massive blackout, all triggered by a storm from the sun. This is space weather, a real invisible threat to our modern world. Our dependence on satellites, power grids, and space exploration makes us more vulnerable than ever. That's why understanding solar storms is crucial, not just for scientists, but for everyone. Enter NASA's TRACERS mission, two small satellites acting as detectives, sent to uncover how the sun's energy affects Earth. They'll fly through the region where the solar wind meets our planet's magnetic shield, gathering data from the heart of the action. By studying this invisible battleground, tracers will help us predict and prepare for space weather. This knowledge is our best defense, helping us protect our technology and our way of life. The sun's storms are unpredictable, but with tracers, we're finally ready to face them. Our story begins with the quest to understand and outsmart the sun's hidden dangers. Think of the sun as a giant pot of boiling plasma, super hot, electrically charged gas. Sometimes its magnetic fields twist and snap, releasing bursts of energy called solar flares. Even more powerful are coronal mass ejections, or CMEs, massive clouds of plasma hurled into space at millions of miles per hour. When a CME is aimed at Earth, it's like a cosmic cannonball heading straight for us. The sun goes through cycles of activity, with solar storms peaking every 11 years. During solar maximum, sunspots and storms are more frequent, making space weather a bigger threat. Luckily, Earth's atmosphere and magnetic field, our magnetosphere, act as a shield, deflecting most of the danger. But the strongest storms can still shake this shield, disrupting satellites, power grids, and communications. Tracers will study how these storms interact with our magnetic field, giving us a front-row seat to the sun's wildest outbursts. Understanding these interactions is key to protecting our technology. As we approach another solar maximum, missions like tracers are more important than ever. The sun's storms can't hurt us directly on the ground, but their effects ripple through our modern world. Tracers is our chance to finally decode the sun's most powerful secrets. When a solar storm slams into Earth's magnetic field, it creates a cosmic collision, disturbing our magnetosphere and dumping energy into our upper atmosphere. This energy lights up the sky as auroras, the northern and southern lights, a beautiful sign of the sun's power. But the effects go far beyond pretty lights. Solar storms can create powerful electrical currents in the ground, called geomagnetically induced currents, or GICs. These currents can flow into power lines and pipelines, overloading systems and causing blackouts. In 1989, a solar storm knocked out Quebec's power grid in just 90 seconds, leaving millions in the dark. That blackout was a wake-up call. Space weather is a real threat to our daily lives. The Quebec event proved we need to understand these storms to prevent future disasters. Tracers will help us learn how energy from the sun triggers these chain reactions on Earth. By studying the magnetosphere's response, we can better predict and prepare for the next big storm. The sun's tantrums are unpredictable, but with the right knowledge, we can shield ourselves from their worst effects. Auroras are just the tip of the iceberg. Solar storms can shake the very foundation of our technology. That's why Tracer's mission is so vital. Our world runs on technology, satellites, power grids, and global communications, all vulnerable to solar storms. Satellites are especially at risk. High-energy particles can damage their electronics, disrupt signals, and even knock them out of orbit. Operators must act fast during storms, firing thrusters to keep satellites safe, but this uses up fuel and shortens their lifespan. Astronauts on the International Space Station are mostly protected, but future missions to the Moon or Mars will face the sun's radiation head-on. Accurate space weather forecasts could mean the difference between safety and disaster for space explorers. On Earth, solar storms can disrupt radio communications, especially for planes flying over the poles. Airlines sometimes reroute flights to avoid outages, costing time and money. GPS signals can also be scrambled, making navigation less reliable. Even our power grids are at risk. Geomagnetic storms can overload transformers and cause blackouts. Tracers will help us understand these threats so we can protect the technology we depend on. The sun storms don't just happen in space, they reach into every corner of our connected world. With better knowledge, we can keep our systems running, even when the sun is at its wildest. That's the promise of space weather science. NASA's TRACERS mission is a new approach to space weather research, using two small satellites as a team of space detectives. Their mission uncover how the sun's magnetic field connects with Earth's, letting energy from solar storms pour into our atmosphere. Unlike massive, expensive satellites of the past, TRACERS is agile and affordable, designed for quick, focused science. The satellites will fly through the polar cusp, a funnel-shaped opening in Earth's magnetic field above the poles. This is where solar wind particles can enter our atmosphere directly, making it the perfect place to study space weather in action. By flying in formation, one satellite behind the other, TRACERS will capture a three-dimensional view of the cusp's ever-changing conditions. The first satellite measures the environment, then the second follows moments later, revealing how things change over time and space. This dual perspective is like sending two reporters into the heart of a hurricane. TRACERS will give us our clearest look yet at the gateway between the sun and Earth. It's a bold mission, designed to answer the biggest questions about space weather. TRACERS' two satellites will orbit over Earth's poles, perfectly positioned to pass through the northern polar cusp again and again. For several months each year, they'll gather data right where the solar wind meets our magnetic shield. Each satellite is packed with instruments, magnetometers to measure magnetic fields, electric field sensors, and particle detectors. Together, these tools will reveal how energy and particles flow from the sun into our atmosphere. The tandem flight is key, like two scientists standing at different points in a river, comparing notes to understand the flow. This lets TRACERS capture the dynamic, ever-changing nature of the cusp. The main process they'll study is magnetic reconnection, when the sun's and Earth's magnetic fields snap together, creating a direct pathway for energy. TRACERS will fly through these reconnection sites, measuring how much energy is transferred and where it goes. This data is the missing piece scientists need to improve space weather models. With TRACERS, we'll finally see the Sun-Earth connection in action. It's a cosmic dance, and TRACERS is our front-row ticket. The mission's discoveries will transform our understanding of space weather. TRACERS will answer a crucial question. Why does the energy transfer from the solar wind into our magnetosphere vary so much? Sometimes a strong solar wind barely affects us. Other times, a weaker one triggers a major storm. Scientists think the answer lies in the details of magnetic reconnection in the cusp. TRACERS will provide the first direct two-point measurements of this region, revealing whether energy transfer happens in big bursts or many small explosions. This new data will revolutionize our models, making space weather forecasts more accurate. TRACERS will also track where the energy goes after it enters the cusp, how it powers auroras and drives dangerous currents on Earth. By connecting the dots between space events and their effects on our technology, TRACERS will help create better warnings. The mission's discoveries will be turned into practical tools for power grid operators, satellite companies, and airlines. Better models mean better forecasts and better protection for our world. TRACERS is the key to unlocking the mysteries of space weather. TRACERS will transform space weather forecasting, turning vague warnings into precise, actionable alerts. Today, predicting space weather is like forecasting hurricanes decades ago, imprecise and uncertain. TRACERS data will let us pinpoint which regions will be hit hardest and when. Power grid operators can take steps to protect transformers, preventing blackouts. Satellite operators can put spacecraft into safe mode, avoiding damage. Airlines can plan efficient routes, saving time and fuel while keeping passengers safe. For future astronauts, better forecasts mean safer missions beyond Earth's protective shield. The knowledge from TRACERS will help engineers design better spacecraft and habitats. With improved models, we can protect our infrastructure and our explorers. TRACERS is a giant leap toward a safer, more resilient future under the sun. TRACERS is a testament to human curiosity and ingenuity, using science to solve real-world problems. The sun gives us life, but it also challenges us with its storms. Instead of fearing its power, we're learning to understand and live with it. As our world grows more connected, space weather science becomes essential to our safety and security. The discoveries from TRACERS will protect our technology and shape our future. Every mission adds a piece to the cosmic puzzle, revealing the hidden forces that shape our world. Thanks to tracers, we're better prepared for whatever the sun sends our way. The journey of discovery continues, with new missions and new mysteries ahead. Next time you look at the sun, remember, we're not just watching, we're learning, exploring, and protecting our world. With tracers, we have our own team of space detectives shielding us from the sun's mightiest storms.